Hello, we're now in Unit 8, so we're going to put this on page 8-1. That's what we talked about in class. Thank you for being flexible. Okay, so your content objective is we will identify the important parts of quadratics and learn how to identify them when given multiple representations. And then you have your heading of quadratic equations. A quadratic equation, we learned this in the last unit that we were working on when we were identifying different polynomials, and we know that if we have a polynomial that is of degree 2, that is going to be quadratic. So the parent function of a quadratic is y equals x squared. So we said that the parent function is y equals x squared, and this is what the graph looks like. We know that it's going to cross right through 0, 0. It's going to hit 0, 0 right there on in the origin. So then it's going to increase equally on both sides, so it's going to be symmetrical about the y-axis. So that means that if we folded it in half, we'd see that both of these lines were right on top of each other on either side of the y-axis. Also, when you have a quadratic, you have a standard form. Well, let me actually write that down. We have a standard form that's always y equals a x squared plus bx plus c. So what that means is that a is the number in front of x squared, b is the number in front of x, and then c is your constant. It's the very last number. So in the parent function, we have y equals x squared. So that means that a actually equals 1, b equals 0, and c equals 0. C is also going to be our y-intercept. So we know that it hits the y-axis at 0. So what I would like for you to do now is I want you to draw this this parabola, this quadratic. So go ahead and just put in the x and y axis, and then I want you to get a rough idea for drawing the parabolas. Make sure you have them just like this. That way we can identify the specific points, the special points on quadratics. So quadratics have zeros, and the zeros are going to be found wherever your parabola crosses the x-axis. So this parabola has 2 zeros because it crosses the x-axis at -1 and also at +5. So we see that it has 2 zeros. Parabolas also have an axis of symmetry, which is the line that if you folded it in half, you would have equal parts on either side. So we have our axis of symmetry, and we should have talked about axis of symmetry in class. We should also have talked about the zeros in class, and if we haven't, that means it's coming soon. So we have 2 zeros here, and then we also know that this has a vertex. A vertex is the lowest or highest point on the parabola, and so this vertex is actually a minimum because you can't get any lower than that point. So go ahead and draw this little graphic organizer, and we need to figure out how to identify quadratic functions when given multiple representations. And we know there are 3 different representations that we are usually focused on. One of them is when we're given a graph, and then another is when we are given a table, and then the third is when we are given an equation. Now, the easiest one is graphs, because we know that if we're looking at a graph and it forms a parabola, then it is probably going to be quadratic. And then if we're given a table, then it should have constant second differences. Constant second differences. And this is something that we will address in class. So I'll put a little star next to it. Address in class. And then the last one is the equation. And we saw at the very beginning is that the equation can be written as y equals ax squared plus bx plus c. And that's how we know if it is a quadratic function or not. So that was it for part 1. Come back tomorrow for part 2. Thank you very much.